Hi guys, so this is day 3 of Parabolas. We're mainly going to be going over, it's going to be some review problems, some new types of problems, and then we're going to throw in a word problem at the end. Okay, so first type of problem, give the focus, directrix, and axis of symmetry for the parabola. So again, I always like to draw like a rough sketch of a picture to kind of help me out here. So with this equation, you can see that the vertex is going to be at the origin, 0, 0. Since it's the y that's being squared, this opens left or right. And since this is a negative, we know that it's going to open to the left. So again, we can just draw a rough sketch here. Focus will be over here, directrix over here. And so in order to find these things, I need to go ahead and solve for p. So I'm just going to do this off to the right here. Remember, I always use the equation for p equals. In this case, it'll be negative 20. So divide by 4, that gives me p equals negative 5. Okay, so then that, remember, is the distance, right, from the vertex to the focus, also the distance from the vertex to the directrix. So then I know the focus will be at negative 5, 0. The directrix is going to be, you're going to the right 5. That gives us the equation x equals a positive 5. And then the axis of symmetry, so I'll just draw it in here. It's the line, remember, that cuts directly through the center of the parabola. So in this problem, it's going to be the x-axis. Okay, or it's the line y equals 0, if you'd rather write it like that. This one is a little different because we haven't necessarily gone through finding all of these things when the vertex is not at the origin. So in this one, I think a graph is really going to help you. I know that it doesn't ask for it, but usually I go ahead and find the vertex first. So the vertex here, remember, we switch our signs. So it's going to be at positive 4, negative 1. So go ahead and graph that. Okay, there's the vertex. Since it's the x's that are being squared, I know that it's going to open up or down. And since 16 is positive, I know it's going to open up. And then I'm going to go ahead again and solve for p. P equals 4. So from my vertex, I'm going to go up 4 units. That's going to give me the focus. So 1, 2, 3, 4. So it's going to be right here, and you can see that point is at 4, 3. You could also see by just looking at our points here, I'm taking that negative 1 and I'm adding 4 units to it because p is equal to 4, and that's what gets me that 3. Okay. Next is the directrix. So since I went up 4 to find the focus, I need to go down 4 and draw in my line right there. So that's going to be at y equals, I'm down at negative 5. If you, again, wanted to use kind of your point to help you out here, you're starting at that negative 1 like we did, and then we're going to subtract 4, okay, to get the negative 5. And then the axis of symmetry is the line that cuts directly through the center of the parabola. So this time it's going to be right here. I guess I didn't draw in. Your parabola is going to look something like that. But this is the line that cuts right through it. So we can see that this time it's a vertical line. So it's going to be x equals. And the value is going to be 4. You can tell here, right, looking at your vertex and your focus, both those values are at 4. Okay. This is another new type of problem. So it says write an equation for the parabola that has a vertex at the origin. It goes through the point negative 6, 2, and it opens to the left. So first we're just going to set up our general equation for this type of parabola. Since it says that it opens down, I know that my general setup here is going to be x squared equals 4py. I don't need to worry about h and k because it tells me that the vertex is at the origin. In this type of problem, they give me a point that it goes through, but it's not necessarily like any special point. So all I get from this point is that it gives me an x and a y value. And since it's on the parabola, I know that I can plug those into my equation, okay? So that's what I'm going to do to solve this type of problem. Set up my general formula, plug in my x and my y values. So I'll plug in, oh wait, I think I skipped one here. Let me go back. There we go. Sorry about that. Going to be the same idea. Let's see. Write an equation for the parabola with the vertex at the origin. It goes through the point 4, -1, and it opens down this time. Okay, so sorry about that. X squared equals 4py. Again, this gives me an x and a y value here. And so I'm going to plug these in. Now I have this set up right. So we'll have 4 squared equals 4p times that -1 for the y value. So what this allows me to do is it allows me to solve for p, which is what I need to do my equation. So then 4 times -1, -4p, and then divide by -4. So p equals -4 here. So then my final equation, I go back to the original and I just plug in the value of p. So my equation is x squared equals 4 times this -4 times the y. To simplify it, I get x squared equals -16y. Okay, so same type of thing. This one says it opens to the left. Again, the center is at the origin. So now, since it opens left, it's going to be a y squared equals 4px. But again, I still have my x and y value because it tells me a point that it goes through. So I'll have, let's see, I make sure I plug this into the right spot here. Y is 2 equals 4 times p times -6. So 4 equals, I multiply, I get -24p over here, and then we divide to solve for p. And I'm just going to go ahead and simplify that fraction. So this is -1/6 is equal to p. So then when I go back and plug it in, I'll get y squared equals 4 times p was -1/6, and then x. And then I just simplify that. That would be -4/6, or -2/3 x. Good. Okay. Write an equation for the parabola, and then it gives us the setup of our general equations. This time, the vertex is not going to be at 0, 0. So, I think we've done some like these before. I think pretty easy to just kind of do a rough sketch so that I know which way it's going to open, so then I know which equation to use. My vertex is at -2, +3, so here, and my focus is at 4, 3. So there. So I know it's going to open to the right, and then I also can find the value of p. I just need to count how far away is the vertex from the focus, and when you count, you should get that it's equal to 6 units. Since it's going to the right, it's going to be a +6. Okay. So also because it opens right, I know that my general equation is going to be that the y's are squared. So we're going to be using this one right here. Y minus k squared equals 4p times x minus h. I can go ahead and plug in my vertex, and I also know the value of p. Those are the two things I need here. So this will be y minus 3 squared equals 4 times 6 times x plus 2. Don't forget to switch your signs for the focus. I'm sorry, for the vertex. So then we get y minus 3 squared equals 24 times x plus 2. That's our final answer. Okay, another one like this. It gives us different piece of information here. So the vertex is at 2, 3. And then this time it gives us the directrix. It says y is equal to -1. If it's y equals, remember that's a horizontal line, so it's going to be down here at -1. So this tells me that the parabola is going to open up, and I can still find the value of p. I find the distance from the vertex to the directrix down here. So when I count, I should get 1, 2, 3, a distance of 4 units. Okay, so that is going to tell me that p is equal to 4. Because remember, I would go up 4 units to find the focus. When this opens up, it's another way I know that p is going to be positive. So because this opens up, I know I'm going to use my first equation here. So I'll have x minus h squared equals 4p times y minus k. My vertex I'll use for hk, and then I know the value of p is 4. So I get x minus 2 squared equals 4 times 4 times y minus 3. So x minus 2 squared equals 16 times y minus 3. There's my equation. Okay. Next couple are just graphing. Again, both of these are going to be review. So remember, if they just give you the equation in standard form, I usually write down first the vertex. In this one, the vertex is going to be at -2, and then you're not adding or subtracting anything to the y, so that's just going to be at 0. Next, I figure out how it opens. Since it's the x's that are being squared, that opens up or down. Since 4 is positive, that means it's opening up. And then I find the value of p. 4p equals whatever that number is. In this case, it's 4. So then p is equal to 1. Okay, so now I can go ahead and graph this thing. -2, 0, that's my vertex. We said it's opening up, and p is equal to 1. So I'm going to go 1 unit up for the focus, 1 unit down, and that tells me where the directrix is going to be. And then my last step is to graph my 2 extra points on my parabola. So I go back up to the focus. I need to go left and right. And since p is equal to 1, remember I double that to get 2. So I'm going to go left and right 2 units from the focus. And that gives me my 2 extra points I need to graph my parabola. Completing the square problem. So I see that the y's are squared, so that's going to stay on the left side of my equation. Put in the blank. Everything else gets moved over to the right, so that becomes positive 8x minus 17 over there. I'm going to do the completing the square part, so -6 over 2 squared is -3 squared, which is 9. So the plus 9 goes in the blank. Don't forget I also have to add 9 to the right side of my equation. So rewriting this, I'll have x minus 3 squared equals 8x minus 8. Then my last step here is to take out that 8 on the right side. Okay, so this is my equation in standard form. So now I can use this to graph. My vertex here is going to be at +1, +3. Since it's the x's, oh shoot, did you catch my mistake? These should be y's out here. Go back and change that if you were copying me. Since it's the y's that are being squared, this is going to open left or right. Since that 8 is positive, it opens to the right. And I'm going to go ahead and solve for p. So p equals 2. Okay. So vertex is at 1, 3. P is equal to 2. So I'm going to go right 2. That's the focus. Left 2 gives me the directrix. And then from the focus, I'm going to go up and down. I do 2p, so 2 times 2 is 4. So I'm going to go up and down 4 units to find my other 2 points on my parabola. There we go. Okay, last one is this word problem. So it says the Parkes radio telescope has a parabolic dish shape with diameter 210 feet and depth 32 feet. The graph below models a cross-section of the telescope. Using the graph, find the equation of the directrix. I think our notes are a little different. Find the equation of the parabola, the focus, and then the directrix. So kind of ignore that part. Okay, so this is kind of like one we did earlier where we know where the vertex is at 0, 0, and we have a point on the parabola. So we're going to use that point to help us find the equation. This parabola opens up and the vertex is at the origin. So the general setup of the equation is going to be x squared equals 4py. And then again, we'll use one of the points. We'll use the one where both our numbers are positive here. Okay, so that's the x and the y value. So then we can just plug those in. So this is going to be 105 squared equals 4p times 32. So that gives me, let's see here, okay. So I'm going to go ahead and solve for p, divided by 128. Now, I'm just going to go ahead and keep everything in fraction form, simplify that down. So when I simplify this fraction, I get p equals, and actually it doesn't simplify. So there's my value of p. Sometimes they will change it to a decimal, so it just kind of depends. I'm just going to leave this as a fraction. So it's asking for a couple things here. First, we want to figure out the equation. So I'm just going to plug this back in for p. So I'll get x squared equals 4 times this fraction here, and then times y. So then I can just simplify that fraction. The 4 and the 128 simplify down. So my equation is x squared equals, so 11,025 over 32, and then times y. Okay. Then it also asks for where the focus is and where the directrix would be. So with that, remember, I'm going to use the value we found for p. Okay. So I know that, like, if I look at my picture here, I would go up that amount to find my focus, down that amount to find the directrix. So for the focus here, that point would be at 0, and then it'd be, what, 11,025 over 128 would be my y value. And then my directrix would be the equation of that line, so y equals negative 11,025 over 128. All right. So homework for this set of notes, Parabolas Day 3 worksheet. It's really similar to the types of problems that we did in this set of notes.